be. So rest assured, we will be. Okay, so then there's the old truss problem. And we're going to be into trusses because I think that's basically the whole next chapter. And these are fun because you can relate to them. Yeah, you could do this. You might have a project at home. You want to do some kind of a truss situation. Make that a little smaller. Okay, so on the top, actually I better make that a little bigger for now. Huh? On the top picture, we're seeing what this truss has going on. It's got a 3,000 pound force right in the center. It's got this 1,000, well, this one's going to give us one with an angle. 1,000 pound force coming off of the x-axis at 65 degrees, pushing on this corner. Now, when we deal with trusses like this for this chapter, we're going to assume that to be just one solid piece. So instead of having all of these members in here, essentially what we've got going on is all of this is colored in. Okay? All we're concerned about is this whole picture right here. Later on, we'll go back in there and analyze every one of those members in that truss so we can tell what kind of forces are acting on those members, because it will be different. Some will be in compression, some will be in tension. Okay, and think about that later on. If we're pulling down on this, then we're actually, when we're pulling these members down here, they're going to be in tension, aren't they? And think in terms of a pin. You know, you're doing this, well, your bottom is going to be in tension. It's pulling it away. The top is in compression. It's trying to push everything back together. So different things will be going on to different members within that truss. But again, we don't have to worry about that right now. All we're concerned with is what's going on here at A, in the X and the Y, and what's going on at B in the X and the Y. This chapter, that's all we have to deal with. Okay? So, and that's what they've shown here in that next picture. You got a reaction. Do what?
AX just because it's on the roller.
Right. AX is on a roller this time. So you'll have to pay attention to that on the test. Where, is Dave throwing you a curveball here? I don't look at it as too much of a curveball because you need to be paying attention to the details anyway. So don't just make the assumption that it's always going to be AX. It won't necessarily always be that way, will it? Everything's not the same throughout. So just pay attention to that, okay? So AX is 0. Yeah, they're just not showing it. I like to just put a line there and put AX equals 0. Then I'm satisfied with myself that I've done my due diligence and checked where the reactions really are, okay? So again, if I were doing a free body diagram of that, it's going to look like this. I'm going to try to write this down here as low as I can so we'll be able to see it better on that next, on our work. So we've got, actually I'm going to have to draw this. Yeah, I'm going to have to draw this like this. Okay, and that's all I'm concerned with right there. Now I've got a force that, and I'm just going to go ahead and draw it. I've got a force that's doing this. This is 1,000, is this in pounds? Yeah. 1,000 pounds cosine of 65 degrees. And then I've got 1,000 pounds sine of 65 degrees. So I just broke that out into the components. See, now after that first chapter, we're doing this it's just piece of cake, right? Somebody say yes. Yep. Make me at least feel better. Okay? Whew. Somebody's getting it. This part of it hopefully is starting to make some sense to you. As long as your angle is coming from the x-axis, you do that. Keep it in that 90-degree quadrant. Becomes easy. Now when we write the equation, and my arrow needs to be a little more pronounced here. When we write the equation, then we'll know that it's a negative value because it's going to the left. Okay, and it's a negative because it's going down. Alright? Well then we've got some other stuff going on here. We've got AY right here, and that is vertical. Again, AX was 0. Then I've got 3,000 pounds right in the middle of that bad boy. So we know that distance to be, what, 40 feet? That's a big old truss. 80-foot truss. It's going to be 2 by 6 at least. Then we've got BY. And now, we got BX. But if you were looking at that, without looking at the answer they gave you, the only force that's acting on this truss that's going in the X direction is this one right here, right? And it's making it go to the left. So therefore, we have to try to counteract that with something going to the right, don't we? Now, I said earlier, if you weren't sure, you could just make the assumption that it's going to the right and going up. In this case, you hit the jackpot, because the force that's the external force acting on this beam, or excuse me, this truss, is pushing down and to the left, correct? Therefore, you're probably going to be pushing BY back up and BX going to the right to counteract those, to keep them still or to keep them in equilibrium. Okay? The one that could be in question would be AY, but then you've got that 3,000 pound force pulling down too, don't you? So with all those forces pushing down, AY is probably helping push back up. But again, if you guess the wrong direction, it'll tell you. Okay? So that's all we have to deal with right there. Oh, well, we do have to put some more dimensions on here, don't we? We would say that this distance right here was 15 feet. And the distance from, I'm going to go from here, A over to there is, what, 60 feet? Right? And the overall distance, I guess we'd probably put that in there, is 80 feet. Keep wanting to put that little curly Q on there. It really doesn't need to be there. Okay? So that's our free body diagram. Let's see. I can get some more room here, can't I? There we go. As long as I don't need that to draw. So, there again, you broke that out into the components for that 1,000 pound force. The hardest part of the problem is taken care of right there, drawing the free body diagram. Now you just go in there and list all those forces. So if I do the forces in the X, I guess I better get on the right device here. Summation of the forces in the X equals 0. We got AX. So we just proved what we said up there, didn't we? Oh, that's not right. It's not just AX. Duh. Now I need to have my eraser back. So we got to do this. We got to get rid of that and get rid of this. Holy cow. That would have been disastrous, wouldn't it?
That was because it's on a roller, AX.
Oh, AX is 0. Thank you. Thank you. Do we need to list that? No. I mean, you just have to put a 0 there. And then we've got what? Minus 1,000 pounds cosine of 65 degrees plus BX. The other BX. Say one thing and do something else. Okay, that's all in the x direction, right? We can solve for that then. Just leave bx where it's at. This goes to the other side and becomes positive, right? So we guessed the right direction. We can tell that. What is 1,000 cosine of 65? $422.6. Pounds, right? End of discussion. Direction. Got to have the direction, right? If I can get that, hadn't been popping up all day long. Now, come on. To the right, correct? 422.6 to the right. So we're done with that. We feel good with that. We'll do sum the forces into y. Try to get all y values this time. Well, we got AY. Go ahead.
Real quick on the test, if we write the answer just like that, we don't have to show all the work of the algebra moving one to the other side and everything, other than just pretty much how you did it.
Just like that, yeah. You did move it to the other side.
Yeah,
Yeah, that's it right there.
all right.
Yep. Okay, then for that one at least, yeah. Okay, so we got AY. It's going up. We assumed it's going up, so it's positive. Minus 3,000, right? And that's the kind of stuff that will get you. You'll forget that one because it's kind of just out there on its own. So just be vigilant and make sure you get all the forces listed. Minus 1,000 pounds sine of 65 plus by, right? That's how I like to do it, because then it just lists them all in order. I've got two unknowns there, so I'll try to make some more room here. I'll get some more paper. I'll do my forces my moment. Again, I'm going to leave some space there. Summation of the moment about point A equals 0 to be in equilibrium. So we've got the 3,000 pounds. That's a negative, right? It's trying to make this thing go clockwise. 3,000 pounds times 40 feet minus 1,000 pounds sine of 65 times, what was that, 60 feet? Okay, that's that y value, right? Plus by. Actually, I'm not going to do that. I was going to do that and mess with you a little bit, but I have to ask you at this point. I don't want to put the by in. I'm going to put in something else. I do have to account for this 1,000 cosine of 65 now, because it does not go through point A, does it? So it is going to create a twisting moment on that structure. Okay? So I have to put in 1,000 pounds cosine of 65 times 60 feet, right? Thank you. 15 feet, isn't it? Whatever, it's that parallel distance. Whatever this is parallel to this, it's the 15 feet. Don't get caught saying 60 feet there. That force, if you did that law of transmissibility, that same force is coming through right here, isn't it? And the distance from here down to there is 15 feet. So again, put your string on that point that you're trying to be relative to, and bring this out and put the string on there, and what's it doing? It's trying to make this thing go that way, right? In this case, which that's counterclockwise, that's going to be positive, correct? So it's 1,000 cosine of 65 times 15 So that's positive value, if I can find it, plus 1,000 pounds cosine of 65 times 15 feet. I didn't put the kilonewtons, well, I didn't on this one either. And let me get that eraser back out. I don't want this. There's actually a little bit of that extra mark kind of screwed up that negative, didn't it? Now I can go in and put in BY plus, let's see, 80 feet, or let's see, BY times 80 feet. BY would be in pounds too, wouldn't it? So now I can go in and solve for BY, can't I? I only have one unknown. So I can leave BY where it's at, and I would, I'm going to go 80 BY. And in that case, Jeff, if you wanted to, you could just do the calculation for that and have BY equals whatever it actually equals. You wouldn't have to carry it out this extra step. I do that so that if there's any question as to where it came from, so that, anybody that's maybe a little rusty on their algebra type stuff, yeah, I think maybe it helps. So now we have to take all of these to the other side of the equation. I've even been known to write that part out. This becomes positive, this becomes positive, that becomes negative. So what do we end up with? For that number, so 3,000 times 40 plus 1,000 sine of 65 times 15
times 60.
Yeah, I was one step ahead of myself. 60 minus 1,000 cosine of 65 times 15. So does that number come out to something like 168,039? That's what I'm showing. I'll write that down. If it's wrong, we'll know here in just a second. 168, I'm sorry. 168,039. And that would be in pounds feet, wouldn't it? BY is that number divided by 80. 2,100 pounds. It came out a positive value. We said it was going up. That means it is going up, right? It's 2,100 what the book said. Get lucky every once in a while. That makes sense? Now we know what BY is, we can figure out what AY is.
It's not negative 16,000
No.
or 168,000?
Now remember, we switch these to the other side of the equation. So this 3,000 becomes positive, this 1,000 becomes positive, and that goes negative. So these two added together minus that. And it's 168,039. And then we divide that out. Okay? So we can put BY up here. We just say 2,100 pounds. AY stays where it's at. Everything else goes to the other side of the equation. So we have 3,000 plus 1,000 sine of 65 minus 2,100. So 3,000 plus 1,000, what was it, sine of 65 minus 2,100. I got 1,806. .3 pounds. We said it was going up. It came out a positive value. Therefore, it is going up. And the more of these you do, the better you'll be at it. And it'll be like, okay, what's hard about this? Don't make it difficult, okay? I haven't talked to the dean yet about the tutoring sessions, but I am going to talk to him about that hopefully this afternoon. So potentially Friday I'll start having tutoring sessions from 8 to 11, so before class. And it may be in this room, I don't know, we'll see. Friday and then Mondays as well, for at least 3 or 4 weeks maybe. And that'll be on stacks and strengths or CAD, whatever. If I can help, I will. Some things I can't. Okay? So, seem to make sense? It's, again, don't make it more difficult than it has to be. Let's see, I think those were the last 2 situations that we need to look at there, really. That cylinder supported by a ball. That kind of, the only bad thing about that is it almost breaks out into looking at what's going on with the different members, and I'd rather save that for some other chapters. I think is what we're going to do there. Okay, so I said, let's see. You want to take 10 minutes? The only thing is we don't have any time after that to work any more problems. We better not do that. Let's work the problems. So let's see. I don't have those captured. So we were supposed to do 415.